Good morning, grade 7. Hope you are all doing well. This is Miss Pamela giving the physics course. Today we are going to start with section 3 in chapter 5, Energy Transformations and Conservation. So if you can all please open your books on page 158 so you can follow up with me. Energy transformations. Most forms of energy can be transformed into other forms. Energy transformation is the change from one form of energy to another. Some energy changes involve single transformations, while others involve many transformations. So energy transformation is when one form of energy changes into another. We can have single transformations and we can have many transformations. Single transformation. In single energy transformations, one form of energy changes into another form in order to do work. So only one form changes into another form. It is one transformation, a single transformation. Examples. A toaster transforms electrical energy to thermal energy, which is heat that we use to toast our bread. A cell phone transforms electrical energy into electromagnetic energy that travels to other phones. So we need to transform the electrical energy into electromagnetic energy to send signals to other phones. So the cell phone transforms the electricity that reaches the cell phone into electromagnetic energy to send the signal to another phone. Your body transforms chemical energy in the food you eat to mechanical energy that you need to move your muscles and into thermal energy to maintain your body temperature. So when we eat food, we transform the chemical energy inside this food into mechanical energy to move our muscles and into thermal energy in order to maintain our body temperature. In the figure in front of you, you can see several examples of single energy transformations. For example, whenever you eat food like an apple, you transform the chemical energy stored inside this apple into mechanical energy that you need to move, to ride a bicycle, to walk, to run. And also you can see that inside plants, light energy is transformed into chemical energy. You can also see that inside a toaster, electrical energy is transformed into heat, which is thermal energy. Now we are going to talk about multiple transformations. In multiple energy transformations, a series of energy transformations occur in order to do work. So not only one transformation, several transformations occur in series in order to do work. For example, mechanical energy, which is used to strike a match. So when you strike a match, you use mechanical energy because you move your hand. This mechanical energy is first transformed to thermal energy. The thermal energy causes the particles inside the match to release toward chemical energy. This chemical energy is transformed to thermal energy and the electromagnetic energy that you see as light. So as you can see in this example, whenever you strike a match, a series of energy transformations occur in order for us to get the heat, which is the fire, and the light that we see at the end. As you can see in the figure in front of you, we have multiple transformations whenever we strike a match. Mechanical energy transforms into thermal energy and electromagnetic energy. Please pause the video, look at figure 10, page 159, read and answer the observing question. The answer is that a lamp transforms electrical energy to electromagnetic energy, which is light. Now we are going to talk about transformations between potential energy and kinetic energy. We already discussed potential energy and kinetic energy in the previous section. We stated that potential energy is the energy an object has due to its position or to its form, and kinetic energy is the energy an object has due to its motion or its velocity. One of the most common energy transformations is the transformation between potential energy and kinetic energy. Why? Because as an object is going up or down, there is a transformation between potential energy and kinetic energy. As the object is going up, kinetic energy transforms into potential energy. So kinetic energy decreases and potential energy increases until we have maximum potential energy, which is at the highest point. So once the object reaches the highest point, potential energy is maximum and kinetic energy is zero because the object will be at rest. As the object is going down, potential energy transforms into kinetic energy, so it is the opposite. Potential energy decreases and kinetic energy increases. So potential energy decreases until it reaches zero. So at the lowest point, while the object is still moving, kinetic energy is maximum and the potential energy is zero. This is the first example for transformations between potential energy and kinetic energy. So the ball is at the highest point. Okay, look at the figure and start from the left. The ball is at the highest point. When it is at the top, it has potential energy but no kinetic energy. Once it's rolling down, so the ball that is rolling down the hill has both kinetic and potential energy. So the potential energy decreases and the kinetic energy increases. So the potential energy is transforming into kinetic energy. When the ball reaches the bottom of the hill but it's still moving, when it's still rolling, it has kinetic energy but no potential energy because it is at a low point. Then when the ball is at rest, okay, and it's not moving and it is not at a high point, it doesn't have no potential energy and no kinetic energy. The second example for transformations between potential energy and kinetic energy is a cyclist. When the cyclist is at rest at the top of the hill, he has only potential energy. When the cyclist is going down, he has both kinetic energy and potential energy, and here the potential energy is transforming into kinetic energy. When the cyclist is riding on flat ground, he has only kinetic energy because he is moving and he has no height, so he is moving on the ground at the bottom. He has no potential energy but he has kinetic energy. So the potential energy transformed into kinetic energy as the cyclist is going down. In the third example for transformations between potential energy and kinetic energy, we have a pendulum. So a pendulum is a device as the one you can see in the figure in front of you. It is like the one used in grandfather clocks. So it goes back and forth. At the highest point of the pendulum has greatest potential energy but no kinetic energy. At the middle point, it has greatest kinetic energy but no potential energy. And then when it reaches the high point again, it will have potential energy and no kinetic energy. So the pendulum continuously transforms energy from kinetic to potential energy and back. So as it goes back and forth, it transforms potential energy to kinetic energy and back. Now please pause the video, look at figure 12, page 160, read and answer the interpreting question. The answer is that its potential energy is highest at the two high points of its swing. So when the pendulum is swinging, it has two high points, to the left and to the right. At its highest points, the potential energy is highest. Now we reach the second part in our section. So our section talks about energy transformations and conservation. We already talked about energy transformations. Now we are going to talk about conservation of energy. The law of conservation of energy states that energy cannot be created nor destroyed. It only transforms from one form to another. So whenever you see that one kind of energy is lost, it doesn't mean that this energy is destroyed. It only means that this energy changed from one form to another. Thus, the total amount of energy is the same before and after any transformation. So whenever we have a transformation, the total amount of energy, all the amount of energy included in this transformation remains the same before and after this transformation. Now look at the figure in front of you. This is an example. We can see a person at the top of a hill. When he is at the highest point, his potential energy is 50,000 joules and kinetic energy is 0 joules. So the total energy is 50,000 joules. When he is going down, he has 20,000 joules kinetic energy and 30,000 joules of potential energy. So the total amount is 50,000. When he is at the low point, he has 35,000 kinetic energy, 35,000 joules of kinetic energy and 15,000 joules of potential energy. So the total amount is still 50,000 joules. At the end, when he is at his lowest point, the kinetic energy is 50,000 joules and the potential energy is 0 joules. So the total amount is still the same, 50,000 joules. So here we can see an example of the conservation of energy. The total amount of energy remained the same before and after any transformation. Energy and friction. There is a relationship between energy and friction and we are going to talk about it now. Whenever a moving object experiences friction, some of its kinetic energy is transformed into thermal energy. So you might think that this kinetic energy is lost, but no, it is transformed into thermal energy whenever an object experiences friction. For example, and it is a simple example, When you rub your cold hands together to warm them up, you are transforming the kinetic energy, because the hands are moving, into thermal energy using the friction between the hands, because the surfaces of your hands are rubbing against each other. So we have friction, and since they are moving, we have kinetic energy. Because of friction, because your hands are experiencing friction, this kinetic energy is transformed into thermal energy. This explains why no machine is 100% efficient, because we always have a transformation between kinetic energy and thermal energy because of friction. Energy and matter. Now we reached a point where we are going to talk about the relationship between energy and matter. Einstein's theory of relativity states that energy can sometimes be created by destroying matter. So we already said that energy cannot be created or destroyed, and it has an exception. This exception is what Einstein talked about. He stated that energy can sometimes be created. How? By destroying matter. Matter is anything that has mass and takes up space. All objects are made of matter. Just as one form of energy can be transformed to another form, Einstein discovered that matter can also be transformed to energy. How can we do that? By destroying just a small amount of matter, we can release a huge amount of energy. Thus, the law of conservation of energy must be adjusted in some situations to state that matter and energy together are always conserved, because matter can produce energy by being destroyed. So whenever we destroy matter, we can produce energy. This is why we should state in some situations that matter and energy together are always conserved, and not only energy. As you can see in the figures in front of you, whenever we have combustion, whenever we burn fuel, we release energy, which is heat, thermal energy. So this is what Einstein was talking about. We can produce energy. Energy can be created by destroying matter. As a homework, please solve numbers 1, parts A, B, and C, 2, parts A, B, and C, and 3, also parts A, B, and C, page 163. Your homeworks must be done and submitted to me on April 7. Thank you and good luck.